Hello, 6th graders. Welcome to Big Ideas Math, Contract Math, Section 6.2, 2012 edition, Surface Areas of Prisms Activity. Pause while you write Section 6.2, 2012 edition, Activity in your math notebook. Pause again while you write today's activity objective in your math notebook. Today's objective is understand the surface area of prisms. Copy the following key terms, definitions, and examples exactly as they appear into your notebook. A prism is a polyhedron that has two parallel congruent bases. The lateral faces are parallelograms. Surface area is the sum of the areas of all the faces of a solid. A net is a two-dimensional representation of a solid. Today we'll be starting on page 141 in your record and practice journal. Our essential question is, how can we use a net to find the surface area of a prism? So here are some representations of a rectangular prism and a triangular prism that remind us of what a prism looks like. And a prism has lateral faces on the sides, and then on the ends it has bases. So the surface area of a prism is the sum of the areas of all its faces, and a two-dimensional representation of a solid is called a net. We'll be working on Activity 1, surface area of a right rectangular prism. We'll be using a net for the rectangular prism to find its surface area. So we have a rectangular prism that is 3 by 5 by 6 units. So when we spread that out, so this is like taking a box and cutting the edges so you can flatten it out. We have lateral faces, and we're going to take a minute to label the lengths of those lateral faces. So this base is 5 units and 3 units, so it's 5 by 3, and then the lateral face is also 3, so that 3 works for both of those measurements. And then the next lateral face is 5 units, so we'll label that, and then going around the end here, it's 6 units, and then 5 units, and then 3 units again, and 5 units, and we have one of those corners where the 3 works in both spaces again, and then this end is 6 units, and then we have 3 and 3. So now that we've got all of our dimensions labeled, we can figure out the area of each of the faces. So starting on the right-hand side, this lateral face, we use our area formula, is 5 by 6. So it is 30 units squared. And we're not going to put in the units squared because there's not really enough space. And then moving to the left, the second lateral face in is 6 units by 3 units, so it's 18 units. And then continuing to the left, in the center, that is 6 units by 5 units, so that is 30 units again. So that's the same as the one on the end. And then continuing to the left, that is 3 units by 6 units, so that's 18 units. And now we'll take a look at the bases. The top one is 3 units by 5 units, so that's 15 units. And the bottom one is 3 units by 5 units, so that's also 15 units. So now all we need to do to get the surface area, since the surface area of a prism is the sum of the areas of all its faces, is we need to add everything up. So we have 2 lateral faces that are 30 units, so we're going to add that in our heads and make that 60. And we have 2 lateral faces that are 18 units, so we're going to add that in our heads and make that 36. And we have two bases that are 15 units, so we're going to add that in our heads and make that 30. And add it all up, and that's a 6, and 6 plus 3 is 12. So altogether it's 126 square units. Let's move on to page 142. Letter B says use the net for a rectangular prism. Label each side as H, W, or L, then write a formula for the surface area of a rectangular prism. So if we look at the picture on the left, we can relate that to our drawing of the net on the last page. The W corresponds to the side with the measurement of 3, and the H corresponds to the longer side with the measurement of 6, and the L corresponds to the side with the measurement of 5. So now we want to label our net on this page with the H's and the L's and the W's. So we have a W here and an L here and an H here and an L here and W here and L on the top and W here, and remember the W is labeling both of those sides of 3. H on the left, W in the corner, and L on the bottom. So now what we need to do is think about what we did when we were multiplying and go ahead and label these 1, 2, 3, 4, 5, and 6. And to get the area for the first box, we multiply a height times a width, or a width times a height. So our surface area is going to equal width times height plus our number 2 box is height on the end times length plus number 3 box is width times height again, plus our number 4 box is length times height, or height times length. That's how I have it down here, so that's how I'm going to write it again. And then our number 5 box is width times length, and our number 6 box is width times length. And then I want to go through and I want to combine like terms. So I want to count all my WH's, and I have 1 here and 1 here. So I have 2WH plus I have, so I'm done with those, I can cross them out. I have 2HLs, 2HL. Cross them out so I don't look at them anymore. Plus I have 2WLs. So I'm going to cross those out. So my formula for surface area looks a lot like 2 times WH plus 2 times H times L, which the book has it the other way. It's L times H plus 2 times L times W. So I'm going to turn it around for you so it's exactly the way you'll see it in your book. And then you'll be all set. Your assignment for this lesson is to find or make a cardboard or paper box that you can flatten into a two-dimensional shape. Calculate the area of each lateral face and base. Add the areas to calculate the surface area of the entire box. Be sure to show your work and be prepared to share during our next class. Please remember, to earn credit for viewing this flipped lesson, you must complete your exit slip, come to our next class prepared with the journal pages or other work from the flipped lesson completed, and be prepared with any work that was assigned in the flipped lesson completed. Be prepared with any questions you have for the teacher, and always have a good attitude. We'll see you next time in class.